in this hepatopancreas health webinar. Today, I would like to present about the use of functional feed and also the culture situation of shrimp in Indonesia. So, if we talking about Indonesia, you know that we have more than 17,500 islands with at least about 99,000 square kilometer coastline. With this area, we have around 300,501 hectares for shrimp ponds. And for intensive system, we have 9,055 hectares. And for the semi-intensive, we have 43,643 hectares for semi-intensive. And the rest is for the traditional farming system is around 247,803 hectares for traditional system. I hope that your geography about Indonesia is good, but this is just to give you some brief information about the traditional farming system in Indonesia. We know that most of the traditional farm is in the north coastline in Java, and then there is an even distribution in Sumatra and also in Kalimantan. And this is about 240,803 hectares for the traditional farming system. Sorry, and now is for the semi-intensive system. We have around 43,643 hectares. We can see that most of the semi-intensive farm in Indonesia is concentrated in Java and also in Sumatra and Sulawesi, and some of them also in Kalimantan. For the intensive farming system, because this is the essential type of farming system in Indonesia. For the intensive, we have around 9,055 hectares for intensive system, and mostly concentrate in Sumatra, Java, and also in Sulawesi. So, from this overview, I think you can you know that about the production system for the shrimp in Indonesia. But if we talking about the export volume from 2017 until 2024. We can see that there is a peak number in 2021 where Indonesia export a lot of shrimp is around 241,000 in shrimp, mostly to South Korea, Malaysia, Russia, and the most export destination is to United States and also to Japan. And then it's going down in 2024 because of the global economical inflation and also the purchase power parity for the consumer. But if we can see that in 2025, in the first 4 months in 2025, Indonesia export around 67,000 of metric ton of shrimp. This also marking an 11 year-over-year increase in terms of the export number. And for the export value, even rose more significantly, is around 575 million US dollar, up to 24% year-over-year increase. And this increase is driven by the improved pricing and also the strong performance in value-added product categories. And Indonesia's shrimp export performance in early 2025 also has been driven by the rising shipments of raw faname and also cooked products, especially to the United States, Japan, and also the fast-growing markets like the European Union and also the Canada. That's for the Indonesia export number and value. But if we look at the global shrimp production system from the Global Aquaculture Alliance survey in 2023, we can see that there are several challenges in global shrimp production. And if we look at the top 5 challenges, we can see that the fluctuation in market price and also for the aquafeed cost, market access, and also the disease prevention is become the most challenge for shrimp production. And for the disease prevention is right now is number 4 for the disease prevention. So we know that if we're talking about disease, if we discuss about disease, this is about the interaction between the environment and also the pathogen and also the host. If there is a interaction between the environment, pathogen, and host, then we can see there's a disease. And disease in aquaculture industry is caused more than 6 billion US dollar economical losses. And this is a big losses in aquaculture is because of disease. If we talking about shrimp, there is an emerging disease and also the existing disease. We can see that for emerging disease, I think Peter already discussed about the acute hepatopancreatic necrotic disease. This has also become one of the nightmare of the farmer right now in the shrimp farm. And also there is another disease like a cotton shrimp disease, and there is a covert mortality nodularis, and there is a neonatal yellow head virus, and a lot of disease for the emerging disease. not only for the emerging disease, and we also have the existing disease. We know that in shrimp, we know about the white spot disease, and also there is a Tora syndrome virus, and there is an infectious myonecrosis virus, there is a Bacillus paname, a fibrosis, black gill disease, and also the isopod infestation. And the impact of disease in the shrimp production, we can see in the case of Thailand, because of the acute hepatopancreatic necrotic disease, the production in Thailand is down significantly from 600,000 until right now is around 200,000. So there is a significant impact on disease in the shrimp production system. But there is not now there is a we know that in shrimp production prevention is better than cure. So one of the preventive strategy is by using the functional feed. And this functional feed, the definition of functional feed is the feed that provide superior performance than if we compare with the conventional feed through the incorporation of the specialty ingredients, or what we call as the functional ingredients, that can promote the growth, they can promote the health function, and also promote the survival of the shrimp. And what can be included is one of such as the bile acid. We can also include the bile acid as the functional ingredients in the diet formulation of shrimp. We can also include the yeast extracts. We can use the phytogenics. We can use the probiotics. We can use the nucleotide, prebiotics, and other functional ingredients. So why shrimp is very vulnerable to disease infection, and how is the immune function in shrimp? So we know that shrimp is very high risk animal to be infected by the pathogen. So they are very vulnerable to the disease infection. This is because shrimp is only do not have any adaptive immune function, meaning that shrimp cannot produce the antibody to certain antigens. But however, shrimp have the a specific non-specific immune function like innate immunity, and the first defense mechanisms is the hemocyte, and then it's supported by the cellular immune response, and also supported by the humoral immune response, such as the prophenol oxidase system, there's a clotting cascade system, or antimicrobial peptides. So this is just a brief overview, short overview about the immune function in Vaname. And if we talking about the hemocytes, this is the first defense mechanism in shrimp. So they are consist with the three type of cell. We know that hemocyte can consist with the granular cell, with the many large, highly retracted granules. You can see on the slides that there is a large granules. This is meaning that this is referred to the granular cell. And if we talking about the semi-granular cells, the granules is smaller compared to the granular cell. And if we're talking about the hyaline cells, there is no granules. So this is to differentiate between the cell in the hemocyte. So we can see that the hemocyte have a three type of cells that can also act as the defense mechanisms in Vaname. So right now, I would like to start about the functional ingredients. One of the functional ingredients that we can use is the phytogenic ingredients. One of my research is by using the hydrosoluble tannins in the feed formulation, and this is how we formulate the diet. We formulate the diet with the low fish meal, low inclusion level of fish meal, and then we include the hydrosoluble tannins with the several inclusion level like 0.1, 0.2, and 0.3. And even though we cannot see any significant difference in terms of the growth performance of the Vaname, but the thing is, by using the phytogenics, such as the hydrosoluble tannins, we are able to increase the number of the total hemocyte count in Vaname. And if compared with the control, we can see on the slide that there is a significant increase in terms of the total hemocyte counts, and also the lysosome activity as the antibacteria in the Vaname. And phagocytosis is really interesting because they have a several function. They can recognize the pathogen. After they recognize the pathogen, and then they can engulf the pathogen and then destroy the pathogen and then release the waste of the pathogen. So this is a very incredible and also very interesting function of the phagocytosis in the hemocyte. So we can see that if you want to see how strong is the phagocytosis function or cell in shrimp, you can see on the slide there is a weak function and moderate function. This is a strong phagocytosis activity, and this is a very strong phagocytosis activity. And then you can see that the stronger the phagocytosis activity, and this is the stronger the hemocyte can also dealing with the pathogen infection. Also, I would like to discuss about the use of another functional ingredients for in this case is a bile acid. I think Peter already explained to you about the function of the bile acid. We know that the bile acid promote fat digestion, and then they can emulsify the fat, activate the lipase, one of the enzyme, and also improve the efficiency of the lipid absorption. And also bile acid can help to protect the hepatopancreas. They can reduce the oxidative stress. They can repair the hepatopancreas injury and also enhance the detoxification function. And one of the nice thing with the bile acid, because they can make liver function is becoming better. They can improve the feed conversion ratio. They can also enhance the growth performance of the vaname and also protect the liver and hepatopancreas function, and also reduce the toxin deposition in the hepatopancreas of the shrimp. So I just bring in one of the research that make my attention here. So this is with the effect of the bile acid, yeah, with several inclusion of the bile acid with the low fish meal diet. We know that right now there is a tendency on the shrimp feed formulation. We would like to reduce more the inclusion of the fish meal, but the thing is, the fish meal is one of the good ingredients because they have a very good amino acid profile. They have a very good palatability factor. They have a very good growth factor. But how about if we reduce the fish meal, and then how is the feed can work well if we significantly reduce the inclusion of fish meal? Then I see that this is one of the article is very interesting. They supplement with several inclusion of the bile acids is 0.15, 0.3, 0.6, and 0.9. And you can see on the slide that the result is by using the bile acid, even with a very low fish meal inclusion, 10% compared to 25%, they have a very good final body weight. We can see that one of the treatment, there is no significant difference with by using the 0.9 gram per kilogram bile acids in the diet formulation with the control diet. So meaning that this, in terms of the cost effective analysis, this can also increase the the efficiency and also the effectivity of the shrimp production system if we can reduce the inclusion level of the fish meal, but at the same time we do not have any negative impact to the growth of the vaname. And we look at the survival rate, even there is no significant difference in terms of the shrimp that have a treated by the bile acid compared to the control treatment. You can imagine as well that if this 15% reduction in fish meal is cost a lot, is can make a farmer can saving a lot on the the production cost, because this by using bile acid, even there is no significant difference in terms of growth and survival rate, then but at the same time the farmers can make more saving in terms of the production cost by using this bile acid. And if you look at the effect of the bile acid in the low fish meal diet on the expression levels of the immunity related genes in the hepatopancreas or the vaname, so by using the bile acid 0.6 and 0.9, there is no significant difference in terms of the expression, and even the expression, the immunity related genes expression is better compared to the control treatment. And now I will also would like to discuss about the other results of my research by using nucleotides. This is one of the functional ingredients as well, because the one that make differentiation between the supplements and additive is the additive is the have a this is one of the micro ingredients that have a specific function, and with this specific function we can produce the functional feed. And one of the functional ingredients that we can use in the formulation of the shrimp feed is the nucleotides, because this nucleotides is the building blocks of the nucleic acid. They're made up of the nitrogenous base, pentose sugar, and phosphate group. And nucleotides also known as the immunomodulator for aquatic organisms. And this is just to inform you how we formulate the diet for the vaname by including the nucleotides in the diet formulation. So here we also reduce significantly the use of the fish meal. We compare first we compare between 10% and 5%, and then we reduce gradually the fish meal, but then we include the nucleotides with the several inclusion level of the nucleotides, namely is a 0.05 and also 0.1% in the diet formulation. And this is the total hemocyte counts. We can see that if we also reduce the inclusion level of the fish meal, but by adding the nucleotides, there is no significant difference in terms of the total hemocyte count, even with the 10% fish meal with the 0.1% nucleotides have a better, highest total hemocyte count. And for the lysosome activity, also have a similar trend with the total hemocyte count by adding 0.1% nucleotides in the 10% fish meal. The shrimp has the highest lysosome activity, meaning that the shrimp has the highest antibacterial activity during the production system. And for the survival rates, after the challenge test, we also challenge the shrimp with the Vibrio parahemolyticus that can become the causative agent of the ESPND with the dose of the 10 to the power 5 coloniform unit per milliliter. And then we can see that with the nucleotides, because this is one of the immunomodulator that can enhance the immune function in shrimp, in non-specific immune function in shrimp, we can see that there is an increase of survival rate in Vaname compared to the control treatment. So there is a ongoing and also there is a growing attention on the use of the functional ingredients to produce the functional feed in order to prevent the disease incidence and also prevent the outbreak of disease during the production system. And another functional ingredients, because this is, I think, become one of the most popular functional ingredients in Vaname, because Vaname also have a special recognition pattern. This is a beta-glucan recognition factors. Yeast can also act as a potential immunostimulation for shrimp. And this is one of our research using functional ingredients, what we call as the double distilled grain solubles. This is a high protein DDGS that still contain with the 25% yeast, and then we use this to formulate the diet. So we include the fermented corn with yeast, this high protein DDGS with 6% and 12% and also 18% inclusion level in the shrimp feed formulation. And then we one of the highest conformated protein, we try to replace the inclusion of the fish meal, and then we try this in Vaname for 52 days, and this is the result. We can see that in terms of the growth performance of the Vaname, we can see there's a significant increase in terms of the performance in final biomass, in final mean weight, and also in the weight gain, and FCR is becoming better with the thermal growth coefficient. This is because the yeast can also modulate the immune function and then enhance the survival rate and enhance the health condition. Then the shrimp can absorb the nutrient better. Then this also convert into the better growth performance in Vaname. And then when we having a challenge test with our colleague in Vietnam, we also challenge with the ESPND, and then we during the 10 days of the challenge test, we can see that by using ingredients, by using functional ingredients that still contain with the yeast to produce the functional feed, we can also see there's a significant in terms of the survival rate compared to the control treatment. And then we have a confirmation study about the use of yeast, because yeast is very interesting in Vaname, because this is one of the special ingredients that can enhance and also modulate the non-specific immune function in shrimp. And then we have a confirmation study with another type of yeast. Right now we use the WM, meaning that this is yeast combined with the monomannan oligosaccharides. We can see that there is a significant increase in terms of the survival rate. Even though there is no significant difference in terms of the statistical analysis, in terms of the growth performance, but we can see that numerically there is a significant increase in terms of the the value, the number of the final body weight, the thermal growth coefficient, the percentage weight gain in shrimp that receive yeast compared to the control treatment. But the most interesting part is the survival is significantly increased by using yeast compared to the control treatment. And also the total hemocyte count before and after the challenge test, we can see there is a significant increase in terms of the total hemocyte count as the first defense mechanism in shrimp, meaning that yeast can also modulate the immune function in shrimp. And if we look at the relative gene expression of the prophenol oxidase, we can see that before and after infected with the pathogen, we can see there is a significant increase in terms of the prophenol oxidase gene expression compared to the control treatment. And this is become a very good result in order to have a very good prophylactic approach in terms of the shrimp production system. So this is the take-home message from my presentation today. what to choose, because functional, there are many types of functional ingredients to produce the functional feed, but please define the purpose on the use of the functional feed. Whether you choose the functional ingredients to dealing with the health condition, or dealing with the stress condition, or to increase the productivity. So each type of the functional ingredients have a different function. So you need to choose what is your your purpose, whether to increase the survival rate or to increase the growth performance. You can also select the different type of the functional ingredients. For the efficacy of the functional feed, bile acid and also yeast in shrimp has a specific pattern to induce the cellular and humoral immune response in shrimp. So bile acid and yeast can be a primary, the primary selection for the functional ingredients to produce the functional feed. And also, please note that the shrimp do not have any adaptive immune function and only rely on the non-specific immune function. So hemocyte become the primary immune function in shrimp because they are become the first defense mechanism. So in order to have a good survival rate, we need to have a functional ingredients that can also enhance and increase the number of the total hemocyte count in shrimp. And also based on the result of our research in our research group about the functional ingredients to produce the functional feed, the inclusion of functional ingredients, for instance, like bile acid to produce a functional feed, can be the solution for the preventive approach in shrimp industry, not only today but also for the future shrimp production system. So thank you for listening for my presentation, and I'm giving back to the master of ceremony, and I'm ready to answer all the questions that you may have. Thank you.
Thank you, Dr. Romi.
Yeah.
Thank you, Dr. Romi, for your valuable insights. And if you have any question about the functional feed strategies or Indonesia shrimp farming, you can type your question in the message box or the Q&A area. Any question? Okay, later you can tap the question.
I think there is a question in the chat. There's a, could you show the table of disease? Yeah, I can show it. So you want me to upload the presentation again, Jackie, Miss Jackie, because so you want to read the question, Miss Jackie, or can I answer directly for the question?
Yeah, you can answer the question directly.
Yeah. So there's a question from Muhammad Adin Azif. Can beta glucan help to increase the shrimp immunity? I would say yes, because there's a specific patterns like the beta glucan binding receptors in Vaname that can also can be induced and also can be enhanced in shrimp, because beta glucan one of the ingredients that can also enhance the immune function in shrimp. So I would say yes. So one of my research also about by using the pure beta glucan, by using the immune priming system, where I immerse the shrimp in the axenic condition, immerse with the beta glucan, and then challenge them. We can see I can also share the result of my publication. So this is I can see that there is some pattern that we can increase the the immune non-specific immune function in shrimp with the beta glucan, especially if you look at the genes, the non-specific immune function genes in Vaname, for instance, like prophenol oxidase and transglutaminase. By using beta glucan, actually we can also increase the relative gene expression on the Vaname. Yes, for this type of question, I would like to say and answer yes, beta glucan can help to increase the shrimp immunity. And then goes to the second question, I think, Miss Jackie, what is the most important pathogen or you have co-infection? So, because of the shrimp is very unique, they do not have any adaptive immune function. So, if in the case of Indonesia, the important pathogen that can cause massive mortality in our production system, I would like to say and make a list. white spot syndrome virus has become the first, the very virulent pathogen in our farming system, and then acute hepatopancreatic necrotic disease also become the most important pathogen, and followed by the with the ESP, the episodic hepatopancreatic disease, and also white facet disease causing by the Vibrio also become important pathogen in shrimp production system. I think I already answered all the questions, Jackie. I think there's another question: is bile acid effective in preventing the onset of ESP disease? I think this is a very interesting, because the ESP, this is a microsporidia, and preventing the onset. I think I thank you for the question. I think, yeah, this is, I think, become the next plan with the Lachance. I think Lachance can also make another research if bile acid is effective in preventing the onset of the ESP, because if we have a better hepatopancreas condition, and also we can absorb the emulsify the fat, and also enhance the liver function and hepatopancreas function in shrimp by using the bile acid, probably they will have a positive impact or positive effect in preventing the onset of the ESP disease in Vanami. Thank you, Jackie.